Hi, everybody. Good morning, good afternoon.
Hello everyone, hopefully you can hear me as well.
Hello, we can hear you.
Fantastic, thank you, Brian.
Yes, I can hear you, thank you.
Amazing, well, welcome everyone to AFRICAST. Bahman's going to start by introducing the team and going through the website, giving you some expectations for the week and what you might learn from it. And then we'll start with Debra with the first session.
Yeah, thanks everybody. So let me go through the introduction slides, and then I think we can share the website and what is included there and how you can actually go through it on your own as well. So my name is Bahman. I'm a professor at Cardiff University in the UK. And with Mitch and Debra, we are the instructors for the third cohort of AFRICAST. I will let Mitch and Debra and Henry later also to introduce themselves, but Mitch is one of the main developers of all the softwares you're going to use for this training and beyond. And of course, for this third cohort, we have a couple of mentors. So these are mainly people attended our previous trainings, and we thank them for their generosity and the time given to support you during this third cohort. And Henry will tell you a little bit more about this in terms of timing as well. And of course, this AFRICAST wouldn't be possible without the support we have from Henry and his team in Kenya. So let me just tell you a little bit about the history of the AFRICAST. So it was in January 2023 that I delivered the in-person training in Kenya. So that was a part of my initiative called Democratizing Forecasting, where we go to developing countries and we deliver in-person training. So I met Henry there in January, and we decided to do an online training as well instead of just having this in person. And that was basically the beginning of AFRICAST. We delivered the first cohort in 2023, and this is the third cohort that we're delivering. In terms of what we assume for the training, well, we assume you know a little bit of R. So you are familiar with, let's say, R syntax. You can use functions, and you recognize what are the functions, what are the different names, and how you can use it. In particular, you should also be familiar with a set of packages called tidyverse. Well, this is also not a statistics course. We assume that you are familiar with some concepts such as mean, standard deviation, quantile regression, normal distributions, and so on. This is also a practical course, so it's not a theory course. We are not going to derive or anything or prove or demonstrate any mathematical equations behind the functions that we are using here. So there is a book that we are using as a main reference. We will put the link to book in the chat. There is this, well, in the slides we have 2021, but I think is this the last version, Mitch? I'm not sure, but anyway, it doesn't matter. We will share the latest version of the book.
This is the latest version.
Yeah, thank you. So we will put the last version in the chat as well, and you can access it online for free. So this book contains a lot of free data sets as well that sometimes you may use for the course, but also you may use it for one of the exercises you have in the website. Well, there is another book that I have written with my co-authors, Stefan Kolasa and Enno Zimson. This book is also available for free. Of course, this book is not based on R. It's just like a introductory to forecasting. So if you're not familiar with forecasting area, I recommend also to maybe look at this book or have it at least as a reference. So this Africa's project is supported by International Institute of Forecasters. We will also provide you with a certificate from IIF. IIF is a non-profit organization that founded in 1982 and is dedicated to developing and furthering the generation, distribution, and use of knowledge and forecasting. So again, if you are from developing countries, I encourage you to go and check out the IIF website. You can become a member, and there is a discount also for those coming from developing countries. And I hope at some point you also come and present in the forecasting conference called International Institute of Forecasters that happens every year in different country. So this also is this Africa's project, and in general, democratizing forecasting is a part of Forecasting for Social Good Committee of the International Institute of Forecasters. So please follow we have a LinkedIn page for Forecasting for Social Good. Well, we don't actually use Twitter anymore, but if you use LinkedIn, and if you can, please talk about this training on LinkedIn and use hashes like AFRICAST and F4SG. So now, before I go further and let Mitch and the team introduce themselves, or at the same time, maybe I actually want to share a brief poll. So if you don't mind, please, can you go to this website, menti.com, and then use this code that you can see there in the screen. And then choose basically the option that is more appropriate for you. So we have two slides, one in your skills in R and another one in skills and forecasting. So I'll come back to this. Mitch, would you like to introduce yourself while people maybe they're doing this poll? And then
yeah, of course, and I'll also go through the website. Bahman, I think you've copied a link when you clicked that code that you could paste in the Zoom chat, a direct link.
Yeah. Sure, let me do that.
And then I will take over the screen sharing.
All right, let me then just put it here. Yeah, so here is the link.
So, welcome everyone. My name's Mitch, Mitchell O'Hara-Wild. You can call me Mitch. I'm from Australia and I work with Monash University. And I'm perhaps best known for the tools that we'll be learning this week about forecasting. This is a range of software available for R that allows you to do time series data, time series visualization, modeling, forecasting, accuracy evaluation, and we're going to learn how to do all of that this week. I wanted to talk a little bit about the website, which hopefully you've been sent the link to. I also put the link in the Zoom chat. Perhaps Bahman, you could put the link there again. This website is where you can find all of the materials for this week. All of the slides can be found under sessions. And you can also download all of the slides by clicking the downloads button and then slides. All of the material here is, of course, freely available online, and we'll keep this website up to date as we run it each year. It's open source, and you're welcome to reuse this in your workplaces, teach other people how to forecast. You can find all of the code available on GitHub by clicking that icon at the top. Perhaps most notable is the recordings for this workshop. Sorry, I'll have to update the mentors there. You'll find the recordings from each day in the schedule. So if you go to the navigation bar, the main page for the website will be the schedule page. And we're going to start the day by talking about the basics of time series, which Debra will go through. And then I'll teach you about time series patterns and graphics in the second session. And if we've gone too quickly or you wanted to go back through the materials and revise, you'll find all of the recordings from this year under the Resources tab. So we've got the recordings from last year, you can see them here, and we'll replace this with the updated recordings for this year at the end of each day. So if you did want to catch up between classes, between days, the recordings are a good place to do that. The other thing you'll find is at the end of your day, at the end of the day, Bahman, do you have the time for this? You'll meet with your mentors to complete a series of exercises. What was the UTC +1 time for that?
Yeah, I'm not sure. Maybe Henry can talk about the mentors, the timing, and because I know there is a WhatsApp group. So
Yes.
he was managing.
I'll talk about that briefly once he's finished.
All right, thank you.
Of course. So with your mentors in the afternoon, you'll work through the exercises. I'll update the websites with the times when I've got them. You'll work through these exercises. And these are comprised of two sections. First of all, there's a learn section. And then you'll find at the end, there's an apply section. The learn section will walk you through how to write the code with some detailed explanations of what's happening in each step. And it will have some exercises for you to follow along and some questions for you to answer. So this should be possible to do mostly independently, but if you get stuck in the afternoon, your mentor will be there to help answer the questions with you. And then the apply section is more of a challenge. Here we'll give you a data set. Today it'll be about BCG vaccine dosages across African countries. And this vaccine is to protect against tuberculosis. And we've set out a little challenge from this data set that we'll give you that involves preparing the data set, so how to make sure it's a TSIBL, a time series data set, fix the missing values, clean it up. How can you calculate some summaries from this? How do you compute new time series? And then visualize the time series to understand the patterns that exist within it, such as trend and seasonality. So this will be a good recap for what we will teach you in the mornings, which is about how we bring in the data, how do we visualize it, and otherwise explore the data. And each day, the exercises will allow you to refresh and test out your new skills based on what you learned in the morning of that day. Henry, did you want to talk a little bit now about the mentor program and the exercises?
Thank you, Mitch and Bahman. Good morning, everyone. My name is Henry Kissinger from Jomo Kenyatta University of Agriculture and Technology in Kenya. And I'm actually the organizer of the AFRICAST workshop together with the other members from Kenya, that's Caroline Mugo. I think most of the things have been mentioned by Bahman and Mitch, but I want just to share a little bit regarding the mentorship. So if you can allow me, Mitch, to just share my screen.
Yes, of course.
Yeah. Yeah. Allow me. What we have is that in the afternoon nowadays.
I'm not yet seeing your screen, Henry.
Yeah, just a minute. Yeah.
Okay.
Yeah. So in the afternoon, that is after the morning session. I think it has been mentioned that we'll be starting the morning session from 7 a.m. UK time and 10 a.m. East African time. So in the afternoon, that is in the evening, that's 6 p.m. Kenyan time, that's East African time. I think that will be about 2 p.m. UK time. We'll be having a mentorship session, and I've already shared some of this within the platform that I'll be able to just talk about. If you download this document and you click up here, you will just see the link that will take you to the Google Meet that we'll be using. In the morning session, we'll be using this Zoom link for the sessions, but in the afternoon, we will be using a Google Classroom where we have different breakout rooms, and in the different breakout rooms, we'll have different mentors. We have different rooms. We have about 13 rooms. You can see the number of people who had shown interest in attending the course. So we have all the rooms indicated by the names Abuja, Addis Ababa all the way up to the 13th. And then on the side, we have the mentors. So you'll be able to actually be able to meet your mentors. As Bahman, as Misha said, most of the work is about you working on your own, but you will also be able to have the mentors to be able to assist you on that. Maybe that is why. So then, finally, again, just maybe share the website. So on this, we have a Google Classroom. I hope you're able to see my screen. Within the Google Classroom, probably some people have not used the Classroom, but within the Google Classroom, what we have here is that we have 3 tabs. The first tab is the Stream tab. Within the Stream tab, if I send any message here, everybody is supposed to be able to receive this message within their email and also within the platform. And you can also be able to send a message. And if you send a message, everyone within the classroom will be able to actually receive. So those who probably joined the classroom this morning, so kindly go through the text that we have shared here regarding the requirements of the course, what you need to prepare for the course, and also any other challenges that you might be meeting, how we can be able to solve them. On the classroom tab, in case there's any material that a mentor would like probably to share with the team, then the mentors will be able to actually create here and then put some material here. But of course, you have been told about the recording. We'll be having that other website on the other side that will be able to actually have the recording for every day. But for the mentorship sessions, we could use this class part here to be able to actually upload any material that you feel that the mentees are able to actually use. Then on the other tab, we have the people. We have mentors here. There are about 26 mentors. That's why you see that in every room we have at least 2 mentors, just in case someone has a challenge, maybe with the network, the other one can come in. But in some rooms, we have about 3 mentors. So we have about 26 to 28 mentors who are ready to be able to assist in this. And then we are currently having 123 people who have at least in the platform. We were expecting about 195 people, but we hope to see a good number of people attending. Finally, I already indicated here, so within this, we expect that you will be able to actually attend the training because, as Bahman has indicated, on a daily basis, we'll be actually taking roll call or maybe some noting of those who are attending the course. And we'd expect that for you to be able to receive a certificate for our attendance, at least you have actually attended the sessions and also be able to participate in the mentorship sessions. So we have, in the mentorship sessions, we have people in that group, participants of about 14 and above. And we hope that you will be able to actually be able to cooperate and be able to assist in terms of managing the group. Even the morning session, we are many, so it might not be possible for us, all of us to be able to actually talk, maybe during the sessions. But to save on time, I think we can be able to use the chat in order for us to be able to actually help in terms of managing the sessions. So finally, I would request that before we begin, if all of us could be able to just indicate their name and institution we're on the chat and be able to pick that. So every day when you join, you can actually be able to indicate, your name and institution. But we'll go through the chat as Bahman and the other team members are going through the sessions, just in case there's any question, and I think that will be handled. So back to you, but before then, I can see a hand from Samuel Kadivani.
Yeah. Thank you. Good morning and good afternoon, everyone. I just wanted to ask, is the time in the evening cast or is it flexible? Because for that time, most of us are probably on the road. Can you have it at 7 p.m. Kenyan time?
Yeah, that could be a challenge, but we could. That's one of the things that really, because of I just forgot to mention one of the things that we also try to find a way is that sometimes the time there could be challenges in terms of the evening time, and we'll be able to, maybe the first day we might not be able to exhaust this, but maybe from tomorrow, because we have mentors all over the whole of Africa. We have people from West Africa and also from this other side of the country, of the continent. So if we have people who are having challenges and we are based in West Africa, we could quickly be able to find a way of actually assigning mentors who can be able to actually help in terms of the timing differences. But for purposes of working, we could start today by working at with 5 p.m. and then we see how it goes. Then any challenges we can be able to handle. I hope that can help Samuel.
Yeah. Thank you.
Thank you so much. Okay, so
I'll also add that you've got the group chat, which you're welcome to put questions in, even out of the mentor time hours that have been set.
Yes. And by the way, if we have any challenges within the Google Classroom, you can always send a message, and I'll be able to actually quickly be able to respond, or any of the mentors can be able to respond very quickly. So for the WhatsApp group, we only have the one for the mentors, but we might think of in future trying to actually come up with a group chat for the other participants, and then we can be able to have people participating. Finally, I know there could be one or two people are attending the sessions for the second time, and there could also be those who are attending for the first time. So what we are aiming at is that even in future, the people who are actually currently mentors actually also attended one of the sessions. So we expect that at the end of this session, you could also be in a position to maybe next year also be a mentor and be able to even volunteer to be part of this and be able to even offer us one or two sessions. And that is what I believe the team is looking forward to, that one day we could also be able to have this being offered by people from the developing countries, and they could be able to just assist or give support in terms of the delivery. Thank you, and back to you, Mitch and Bahman.
Yeah, Bahman, did you want to go through the polls?
Yeah, just one. Is
Have we got enough
Debra
data
here?
yet?
Not sure if Debra is here, or you can maybe briefly introduce yourself. Debra, you're here?
Yeah, I saw Debra here earlier. There you are.
Yeah. Thank you. Thank you, Bahman. Thank you, Mitch. Hello, everyone. I'm Debra Okeh. Yeah, I'm a cohort 1 fellow of the Nigeria Malaria Modeling Fellowship and also a global health physician. My pleasure to also be part of the facilitators in this session. Thank you.
So one thing I'm particularly proud of, and I think Deborah's underselling it a little bit, is that Deborah was actually one of the participants of this course before, and then last year was a mentor and has taken up the opportunity to present and instruct one of the modules for today. So it's very brave and very impressive what Deborah is doing for AFRICAST this year. And I want to inspire through Debra to a lot of you to sign up to be a mentor next year, and then think about becoming an instructor in the years to come as well.
Thank you.
All right, thanks everyone. So here we have actually two slides. I don't know whether you can actually go through the second slide, or is there anything with the setting that I didn't do right? Oh, okay, I can see that you can do it. So, and then in a minute I'll go through both. So the first one is about your skills in forecast in R, and the second one is in forecasting. So I'll give you maybe a minute or so to complete this, please. So we put the link for this poll in the chat, and you need a code to be able to vote. It would be great to have as many as you, so you can have a good understanding of your skills in R and forecasting. All right. So it seems like we have about 30 people voting here. Okay, so I think yeah, the good thing is the majority of you, at least voting, you are familiar with R, and this is good for us as well because we assume that you know R. I mean, for those of you are not familiar with R, maybe, well, this is an opportunity as well to learn R, and we encourage you to invest a bit of more time on learning R, and later you learn how to do forecasting with R as well. So this is encouraging. And when it comes to forecasting, well, at least from this poll, we have about 12 people. They feel comfortable. We have even one that is skilled in forecasting, so that's good. So you can always also help others, but here in the training, but also later in the mentorship. So it's great to have you on board. And for those of you who are not familiar, or like you're learning or you're beginner, please do not worry at all. So this course is designed to help you to learn forecasting, and in particular, how to do forecasting using R. So maybe I'll stop the poll, and then I'll go back to my slides. I think I have only one or two, and then leave it to Debra. Yeah, so for this training, we need a couple of packages, and as we go, we tell you which packages we are using. But two main packages we use are FPP3 and Tidyverse. So if you already install R and R Studio, you can install these two packages. And if we need more packages, we let you know as we do it. So these are the topics we cover in the training. So today, Debra is going to talk about basics of time series and data structure. And following that, Mitch will cover time series pattern and basic graphics. So this is basically today. And then day 2 tomorrow, Mitch will cover both sessions on transforming, adjusting time series, and computing and visualizing features. And then on day 3, I will cover basic modeling and forecasting, and Mitch will cover forecasting with regression. On day 4, I will cover exponential smoothing, and then Mitch will cover ARIMA models. And on the last day, on Friday, I will talk about forecast accuracy, so both basic training and test accuracy, and also residual diagnostics and time series cross-validation. And as you can see here, in this column, we have chapters corresponding to the FPP3 book that we shared in the chat. So for each session that we have here, you can also find the corresponding chapter of the book. So if you need to read more and learn more, you always have the opportunity to do it. So in terms of the schedule, as we said, the schedule actually is 7 a.m. So instead of 8, we decided to start a bit earlier. So 7 a.m. UK time. And then we have 7 a.m. to 8:30 for the first session, and then we will have a 15 minutes break, followed by second session. And then later you talk about, I mean, Henry kindly, talk about the mentorship, and then you manage it through basically Google. And I think we have covered this as well. All right, so I think I can leave this to Debra. If there is any other question, we can maybe answer before going to the session. But if not, Debra, you can maybe share the screen. And thank you for supporting the AFRICAST Cohort 3 this year. We are very proud to have you on board this year.
Yeah, just echoing what Henry has put in the chat. If you could all put your name and then your organization, just so in the chat, so that we can record your attendance, so that you can get your certificate at the end.
Hello?
Yeah,
So,
Debra? Yeah.
all right. So thank you once more, Bahman. So today, this session is basically about what time series is, and also we'll be looking at the structure of time series data. So from a statistical point of view, forecasting involves using a model to summarize past observation or past behavior, and it's intended to try to pick the pattern of that behavior. So from this chart we are seeing on the screen, that would be the black line. So we're trying to pick this past behavior. We are seeing the repeated up and down patterns. And that is at the point when the forecast is being done. That is at this point, we have this these dashed red lines. So for instance, you might want to imagine what the forecast would be. So what do we expect to get as a forecast given this data? Do we expect maybe a flat line? If we get this, it wouldn't really be a good forecast because it's not giving a similar pattern as the historical data that was summarized. And then again, we also don't expect the data to be off. So for instance, the data being below at this point or being above at this point. So this is because, as we can see, we don't expect the data to also be off at this point. So because we can see the center of this data is actually at 450. So we would expect the forecast to also capture these repeated up and down patterns we are seeing here. Okay. Then, of course, we would also assume that this pattern of the historical data will be maintained in future. And that underlies the assumption of our forecast. So we'll go on to also ask, why would we want to, when we want to forecast, what do we need to forecast? So first of all, we would need the data of what we want to forecast. So for instance, if we want to forecast population, we would need data from the past, maybe from past census that has been conducted in a country. It will give us a sense of what the data is, what the population of the country or the region has been over time. And we can actually, of course, visualize that data to see the pattern, and it can give us a sense of what we should expect going forward. Then what next we would also need would be, for instance, we also need to include other information. For instance, if we want to forecast population, we may need to also include information on GDP, information on income. And in this case, if we want to predict population, then we would need some of this information as well. As we go on in other sessions of this workshop, you'll get to see how all these other information can be included for our predictions. So for instance, if we want to also forecast population, we'll also need future data of these GDP income to also help to improve the accuracy of our forecasts. Then we might also need data on other stochastic processes that can affect population. So for instance, things like rate of birth and also rate of death, and even information around the migratory patterns All these can also be included, even in the model to also enhance the accuracy of the forecast. Then if we want to also get information on something that there is no, or there is limited data existing about, in that case, we would need to use the expertise on anecdotal information of people who are experts in that field, and at least that would help to also shape the forecast given their contextual knowledge. Then why do we use forecasts, both as individuals and as an organization? So generally, forecasts are done for purposes, and it's done mainly to help inform decisions and also to have evidence for actions which can be taken by either individuals or even by organizations. So for instance, on an individual basis, I may already have maybe data on maybe how much I spend, and based on that, that will help me to forecast maybe how much I'm going to also spend in the next week or in the next month. And I can use it to plan out maybe any income I'm expecting. Then at the level of organization, so for instance, we may want to know whether would there be need to build maybe additional hospital. So for instance, in that case, if we look at the data we have already on the population of maybe women within the reproductive age, maybe women between 15 to 49 years, if we already see that the forecast of population is already showing that in the next 10 years, the population of women in that category are going to double, then that gives us a sense that in the next 10 years, there's going to also be increased need in services for women and children in the next 10 years. And for planning purposes, the authorities or the program managers can decide to proactively begin to put together resources to build a hospital ahead of time. Then again, for instance, during emergencies, there is need to set up hotlines, call centers, because people will have questions. So how do we know the staffing that is required for these call centers? So if we look at the number of calls that were managed maybe this week and how much time that was taken, and if we also look at maybe projections of maybe assuming the emergency is still evolving, then we would expect that we may also need more staff in the call centers. And of course, if we also see that the outbreak is also receding, then again, it will help us plan to know that we may need to also reduce the number of staff in the coming week. Then again, for planning of both for vaccine that will be required in our health programs, forecasting also helps. If we know, we try to get the data of the population, the target population who are expected to be vaccinated, and based on also the season. So for instance, some diseases are seasonal, maybe flu, measles. So also depending on the season, you may look at the data from the last year, and if you see that during a particular month or particular period, there is usually an increase in the number of maybe need for doses of vaccine in that particular period, then that also helps program managers to also plan ahead of time and stock up these vaccines to ensure that they are available and there are no stockouts. So generally, forecasting is used as a tool for management and planning. So from what we said, how is forecasting? What's the workflow? So generally, first of all, would be which kind of questions or problems require a forecast or to assist in making the decision about it. Then when we identify this problem, next would be to now come up with the data needs to actually forecast or enhance the forecast of that particular thing we want to forecast. After that, we'll go ahead to now identify sources of this data. They can be already existing data, maybe data from surveys or data from Or we may need to collect primary data in some instances. Then this data is put together. Then we need to prepare this data. We'll get to see in the course of this workshop how to prepare time series data for forecasting. Then we'll go ahead to now visualize the data. So in the course of this, for today, we'll be looking at these aspects. We'll be looking at these aspects. We'll go ahead to, this is what we're going to look at, how we would actually also prepare our data for forecasting. So at this point, I will be looking at the packages we'll be using in the course of this workshop. We've been told earlier to install the FPP3 package. So this is the packages we'll be using. Would include the Sybil data, which is the data for forecasting for time series. Then the FIST is used to visualize the data. Then Fable is a package that helps with forecasting. So looking at this data, what can we see, or what's our observation? You can drop it in the chat. What are our thoughts? What does the data we are seeing, what do they have in common, or what can we observe? You can drop your thoughts in the chat. Okay, yes. So good. I've seen a number of comments, and they all point at the fact that the data all have a time aspect. So for instance, the 4-yearly Olympic winning times. So in that case, if we are setting up a time series data for this, we would expect maybe the time frequency to be, maybe if we start from 2000, the next one will be 2004, 2008, and going forward. Maybe till we get to 2025. Then we can also see for business that might be reporting their profits. So usually it might be, most times it's reported annually. And in that case, the frequency would be 1 year. Then also we are also seeing quarterly frequencies down to monthly rainfall. Then we can also see that the frequency can also be granular, even up to 5 minutes, and sometimes even up to the second, okay? So the important thing is that when you have your data at lower frequencies, for instance, if you have hourly data, if what you want to work with does not require the level of granularity, you can go ahead to aggregate hours to days, or days to weeks, and as the need arises. But most importantly, it will help if this data is collected granularly, but because you can actually aggregate up. But if we have data that is already collected at a yearly basis, then it's difficult for us to actually now work with time interval that is less. So importantly, that's an important element of time series data, which is that the data has the time aspect. So so at this point, we'll also be confirming that, have we been able to install the FPP3 package? So at this point, we'll go ahead and we can actually go ahead and library the FPP3 package. So if we run the library FPP3, it's actually going to import all these other packages. So these are essentially packages in the tidyverse, and also packages that help to manipulate data, and also packages that help us to work with the time series data. So, for instance, if we go to R, so to bring in those packages, we would do library FPP3. We'll run that. So that should actually get our packages attached. So these packages are part of the tidyverse package, and we've also seen the packages that we use for time series data. So you can actually try that yourself. If there are any questions, you can drop them in the chat box. Okay, so next, okay, I don't see any question in the chat box. So next, we'll be looking at one of the data sets in FPP3 that's already in our materials for the workshop. So this is this data set is the global economy. And one thing we have to note about this is that when we want to consider a symbol, so symbol actually is a time series data. It's like the time series of table. Table is like a data frame in R. So what we see, it would actually be a time series data will have the index data, which actually speaks to the time interval of that data. So for instance, as we look at this data, so looking at the screen, what can we identify as the time aspect of this data? And what's the frequency? You can drop that in the chat. So what's the frequency we can observe of the data that we are seeing of this global economy? Is it monthly? Okay, good. yearly, good. So it's yearly. And so that speaks to the interval we are seeing. So for instance, if we take a look at here, we are seeing the data 1960, 1961. So under this column of year, here, we are seeing intervals of 1 year, 1960, 1961, 1962, 1963. So that speaks to the index of this time series data, okay? So we can also see it over here. We can see it noted here, 1 year. So for a stable data, this gives you, if you look here, you see the index, it gives you a sense of the time interval of that data. So one important thing about time series data is that at any point in time, you normally would have just a single value of a particular, that's the measured variable. So for instance, for this data, this is the index. The next thing we would want to know is the key variable. So the key variable in this instance is what? Is the country. And that is the identifier for the data. So in this case, the key variable is actually the country. And we can see 263 time series data of country across imports, exports, and population. So these are the key variables. Then these are the measured variables. These are the measured variables. And these are the things that we can actually forecast from the data. So we can actually look at that in R. So moving to, we'll just bring in the global economy data sets. So what can we see? What are observations? Let's drop our observations or questions in the chat. I don't know why. Okay, so here we can see these SIBO. In this case, we are seeing the SIBO comprising of 15,150 rows across 9 columns. And this is actually showing us the various, the country, the year, and the GDP, the imports, and the population. So we have 263 countries. This is actually a large data set. And generally, from this now, it helps us to actually make our forecast of either population or any of these variables we are seeing here. So moving on. So as we explained, the index is actually the aspect that captures the time aspect of the time series data. Then we have the key variable. In this case is the country. Then again, we also have the measured variables. In this case, the imports, the exports, and the GDP. So then again, we can also look at another data, which is tourism. So this tourism also, from our observation, what are observations about the tourism data? What's the frequency? Okay, so if we take a look at this particular data, what's our observation? What's the frequency of this data? We can drop our observation in the chat box. Quarterly. Okay, good. So this is actually the data on the number of visits to Australia, to a particular region, and the reason for the visits. So we can actually also take a look at that in R. So let's bring in the tourism data. We type tourism. So this shows us the data of visits to of tourists. So in this case now, the index is the, let's highlight that. So the index, which shows the time frame, is actually, this is it. The quarter, as earlier mentioned by most of us. So this speaks to the index. This is the quarter. Then for the key variables, what can we say about the key variables? So what are the key variables in this instance? Can you drop your answers in the chat? Okay, yes, some say purpose. We can see region, state, and purpose. Good. Yes. So that's interesting. So in this case, we're actually dealing with a data set that has multiple key variables. So one interesting way to identify key variables is that, you know, they have their characters as they come as text. So for instance, in this case, we can see this, the region, the state, and the purpose. So these are the key variables in this particular data set. And next, what is our measured indicator now, which we would want to forecast? That would be the trips. Okay, So these are actually the number of visits that that were made to Australia. Okay, so let's see if there are any questions. Trips, good. So that's our measured variable in this case. And in this particular case, we can see that the index is clearly indicated here, which is quarterly, okay? And we have the key variables, that's 304 key variables. So that's also quite appreciable time series data. So just for us to know that this, as we saw, the global economy and even this tourism, we can see they are all civil objects in which we have our time series data stored. So we'll also go ahead to make sure that at this point, just to know if there are any questions around index or key variables, and would like to also get that sorted out. So generally, a Civil allows us to actually store data and also manipulate this data in time series in R. And we've been able to show the various Civil data which we've used in our past examples. And interestingly, you're able to manipulate this data using the tidyverse functions, which we'll also use a lot of it in the course of this workshop. So coming to the creating a Civil now, like we've explained before, so Civil is the table for time series. So you can actually create Civil, using this function. So in this case, but more importantly is that we can see that this is a Civil, and how do we identify or a data set, knowing whether from a table, differentiate between it being a table or a Civil. So in this case now, we can see this, sign. So we can see this. Once we see this in a data frame, that gives us the frequency or the index of that data, then we are dealing with a Civil. So we can actually create Civil data for forecast, but most times we actually use existing data, okay? Most times we actually use existing data, which like we've mentioned, the various sources of this data, and these data are available, and we go ahead to use it. It could be from health, from various sectors of the economy, and this is what we use for our forecasts. So one thing we've seen forecasts that are yearly, but it's also important for us to know that, and even more than yearly, but it's also important for us to know that there are instances where the frequencies happen more than once per year. And in those instances, we have to, use, time class functions on the index. So as we can see, for this particular data now, this is data that has monthly interval. So, but this is just a table because we cannot see that frequency clearly shown. But in this case now, this particular data at this point, what we are seeing now is a Civil, and we can already see the monthly frequency clearly indicated here. So this is it. So, and how did we so for this particular, to create this table, we use the asTable function. And in this case, you have to now indicate for the table data we showed earlier, to create this table now, we now have to include this asTable function. And in this case, we have to indicate that the index equals to month. So this is what is very important, to actually change table to table. So we'll move forward. So as we have seen, for data that have frequency more than once a year, it's important to actually create time index variables. So for instance, if we want to create that based on the frequency for annual, these are the functions. For quarterly, for monthly, you include the year month function. Weekly, you add the year week function, as the case may be. So we'll also go ahead to see how to also convert. We can also convert various types of data to table. So for instance, we have data in our exercises. We have data which is the prison data from a prison in Australia. So at this point, we are looking at the data frame, which is just the table. So here, can we also identify what is the frequency of this data? Can we drop our comments in the chat? Okay, so we say quarterly. Then what can we say also about the, okay, so we can already see the quarter. So what can we say about the key variables in this case? Okay, gender, legal state. Yes, what else? What are the key variables? Okay, good. So this is another instance where we have also multiple key variables. So in this case now, to be able to create this new variable quarter, we can use the mutate function from tidyverse. So if we look at what we had initially, at this point, you can see that we just had the date and there was no variable called quarter. So at this point, it's not actually, clear what the, the time interval is, okay, because we are seeing both the date, day, year, month. Okay, so when it's in this instance, it's easier to actually now create the new variable called quarter. And in this case, we used the function of the time index as we showed earlier. So we will include mutate and I want to create a variable quarter, and we'll now indicate that this quarter this quarter equals to year quarter and this variable, which is the date. So this was what helped us to get this variable that is now quarter, that is clearly showing Q1 of 2005. And as you go down, you see Q2, Q3 ongoing. So these are all some of the necessary ways we have to prepare our data, even as we want to make our forecasts. So we'll also go ahead to see other functions. So also, since we've already created the this variable, which is quarter, so we can actually also manipulate the data set. So for instance, in this instance, you can see using the select function, in this case, we can see minus date, this. So with this, the date column was dropped from the data set. And clearly, we now have the quarter as the index. So we'll also go ahead to see other ways we can also manipulate the data. So then again, for the same data now, all the while we've been seeing it as a table. So now we want to now convert it into a symbol. So we can see at this point, the symbol function was introduced, and the index was clearly indicated, which is the time, which is quarter, the quarter variable. Then also the key variables were indicated. So just as in R, you use the C, that's the combined, then we listed the key variables which we had all earlier identified, which is the state, the gender, the legal, and the indigenous. So all these were now run to now get this symbol. And like we said, if we see symbol, we will all see it clearly. The index is clearly indicated, okay? And here we can see that the key, we have a 64 time series in this data. So if we have any questions, we should feel free to drop it in the chat as we go on. Oh. So next, we'll be looking at a data set about Australian pharmaceutical sales, pharmaceutical benefit scheme. So in this case, we have a data set from the scheme that shows how the government is able to determine the cost of drugs and how they also try to forecast the drugs they would use. So in this case, maybe let's go to R. So we'll bring in the PBS data. So already what do we think? We can already see the frequency. That's the index of this data, which is this. So it's 1 month. And what of the key variables? We can also see that this data also has multiple key variables: concession, the type, ATC1, these are all the variables. And also, these are the key variables. Then in this case, what is the measured, what are we trying to forecast? Can you drop it in the chat? Let's see. Costs, beautiful. So we're trying to forecast the cost. So we'll just try our hands on how to prepare our data for forecast. So for instance, for this data now, we may want to, let me clear this first. So to get certain rows of this data set, so let's try to filter. So apply filter from multiplier, filter, ATC2 equal to, okay, we are seeing A1. So maybe let's get maybe A5, A10. So now this is a means of getting certain rows from the data set. So in this case, we've been able to just get only the A10. Then also, we can also use the select function to also select particular columns from this data set. So for instance, with this now, we'll just include, let me just do it again. So with this now, if we want to just select, let's say month, concession, type, we'll come here and include select. Then we put month. What else we want? Concession. Then we can also put type and cost. Type and cost. Then here, I'm missing out something here. So now when we run this, we see that just these columns are selected from the data set. Then again, we can also want to also summarize over keys. So we already know the key variables. So we want to now add up, across the keys. So in this case, when we have this, so we'll just add the summarize. So we'll say summarize summarize. Okay. Total underscore cost, which will be a sum of costs. So we'll run this. So in this case, we've been able to summarize across these the key variables which we earlier identified. So these are some of the ways we can actually work with our data set, with our SABLE, in order to prepare it for forecasting. So we'll go ahead to explain this. Okay, so we've seen this. Then another thing we can actually do is to actually create a new variable. So for instance, when we've gotten the total cost at this point, so we may also want to make it clear. For instance, we are seeing is 3,500,000. So for July 1991, we are seeing 3,526,591. So in this case, we just want to maybe create a new variable, and we want that variable to have this total cost, in millions. So in this case, we use the mutate function, as we are seeing it here. This is the mutate function to create this new variable total cost, and to now make the total cost to be divided per million. So we now have 3.5, million as the total cost. So these are some of the ways we can actually manipulate our data and prepare it for forecasting. Then we can also use the mutate function also to, I think it's the same thing. In this point, we also created the new variable and divided it by the million. So generally, I think that is it for this session. In the subsequent session, and in the course of this workshop, we'll get to see how to also prepare our data and visualize our data before forecasting. So if you have any questions, you're welcome at this point. Thank you. Mitch, please feel free to add.
No, fantastic work, Deborah. You've said everything that I would say. I am very impressed. So I want everyone to please join me in thanking Deborah for taking on that first session. It's not easy to front everyone and prepare and present as eloquently as she has. So please join me in thanking Deborah. And of course, if you've got any questions, now's a good time. We've got about 20 minutes before we start the next session.
Maybe there are a number of people who probably have challenges with installation, so I think we can be here for the next 20 minutes so that we can be able to sort a few of them. Okay, as we wait, we are meeting the next 20 minutes. So if you have any challenges, please just let us know. And we are happy that Deborah has gone through the first session. Thank you, and I'll meet you in the next 20 minutes.
Yeah, that's a great suggestion, Henry. If you do have issues with installation, we'll try to resolve them now.
Yeah.
Otherwise, it's something you might have to work through with your mentors this afternoon.
Yeah.
But we might be able to solve some of the easier ones.
Yes, Babatunde.
Thank you so much, Debra, for the wonderful lesson. Yeah, I'm also I'm also a fellow from Nigerian modeling. So yeah, I can resonate with most of the things you've taught. And I'm really proud that you are here at this moment to do this. Okay, I just need your probably the code you shared earlier, the code you were working on your R. I'd like if you can probably have the comment of what each code does, and if you can probably share them. Yeah, thank you so much. That's it.
Okay, so thank you very much. So the materials are actually available. I think Mitch showed where we could have. So we'll actually make these materials, the materials will be shared, okay? And the codes are all available. They're actually available on the website as well.
All right,
Maybe
thank you so much for your response.
During this break, if those of us who probably do not have a problem with the internet, with their software, you could quickly download the materials online for the day one. You'll be able to get them. And I think after the break, Mitch will take us through. And we expect the second session to be more practical. So we expect that you will also be working in the background.
Can
Yes,
I
that's
just
right.
add, sorry, one thing? So for the video and also the live coding, so Debra did some live coding. We will upload those also on the website, but it may take maybe a day. So for after this session, I think we will upload them. So you will expect to see them maybe tomorrow for each day after. And one more thing, I think I realized some of you may miss the beginning. If you haven't done it, could you please put your name and your organization in the chat so we can have those attended the sessions for the certificate that we provide at the end. Thank you. And if you have questions, because I saw someone said you have questions, so please raise your hand and you can speak.
Hello, this is Wandaya. Do you read me?
Yes.
Do you read, sir?
I can hear you.
Nice. Thanks so much. It's very wonderful session. I've got a lot of things. My name is Wandaya from Ethiopian Bardar Mercy with statistics with masters with BSc background. Just I have seen the such session with very interesting thing. I've learned a lot of times about some time series data. But I have one question which I encountered every time when you have taken the course. Is there any means to be composite when there is a missing data? Most of the time, just in Ethiopia, there is meteorological data, which is most related to time series. But there is a lot of times we encounter missing data. We get a lot of missing data. And when we try to apply missing data compensation method with other statistical method like missing using technique mean or any other missing compensation technique, is it possible to do that, or is there any means to solve such problem, missing data problem? Thank you.
Yeah, I could take this one. It depends on what you're wanting to do with your data, and the missing data will cause various challenges depending on what decisions or what results you want to get from it. Some of the models that we will cover this week for forecasting do work with missing values. Others will not, and I'll try to remember to mention which ones do and do not as we introduce them. Another consideration is when we come to visualizing data that has missing values that I'll cover in the next session. Often it's common to draw a line between observations, even if there's missing values in between. And that's a sort of guess for what happened in between, and that can be misleading. So it's better practice usually to just draw a gap without connecting the lines if there's some missing values between them, because we don't really know what happened in that missing observation. Other than that, you could apply interpolation, so using a model to fill in the blanks for when there is a missing value. But for time series, that can be particularly difficult because you need a time series model that can forecast those missing values?
Sure. That yeah. Just we have done. I'm just done a lot of data type. I have encountered a lot of data type. When we try to apply multiple imputation or mean or any other just compositing technique, just time series data is difficult to do that. Just missing something
That's
is
right.
very difficult. Yeah, the nature of the data is not suitable for just feeling missing with the missing technique. That's what
So one of the
I have
issues of
challenged
using
so
the
far
mean,
for a lot of times.
one of the issues with using the mean to interpolate missing values is that it doesn't handle the temporal correlation, the temporal structure that exists in the data. So it's more common to replace missing values with either the previous or the next known value. And that's equivalent to a naive model that we'll see. Another model that you could use that we'll see, I think, on day 3 of AFRICAST, it might be day 4, let me check that. It's the ARIMA model. An ARIMA model it's day 4. ARIMA models are able to model time series that has missing values, and you can also forecast from data that has missing values and interpolate the missing values as well. Bahman has a point.
Yeah, sorry, just one practical thing when it comes to missing value. Probably when I observe missing values in the data, the first thing I do is, instead of just going and trying to fill them or interpolate, is to understand why those missing values occur. So if you could maybe use the domain knowledge of those they collected data, or basically they are closer to data collection, those people, if you can understand why the missing happened at first instance, that may help you to come up with something that is more you know closer to the reality of missing values. And actually many like practical time series forecasting I have done with organizations, the best things we could find is, just as Mitch said, depending on, again, the time series, maybe just use the previous week, or something like that. But anyway, my point is, I think what matters when it comes to missing value is first to understand it, why it happened in the first place.
Thanks so much, sir.
Delight Abdi, do you want to ask your question?
Some other hand from Delete.
Yes.
Delete, your hand is up. Abby.
Yes, can I go ahead?
Yes, please.
Okay, so I asked a question on the comments about the time duration for a time series model, because I have a data which is weekly, and I try to use 3 years period, but then I am told that the year is too short. So I want to know the best duration that one should consider when fitting such model. And also I realized that in most of the data we have other external variables, let's say like environmental variables that influence, for instance, the incidence of a disease. So how do we capture that in a time series model? Thank you.
Bahman, are you able?
Maybe I will start, and then Mitch, I think you can add definitely to this. So I think the first thing is, I mean, this is a good question, by the way. So what is the best sort of time interval? So there is no really best time interval, I would say, when it comes to forecasting. So first of all, you need to see what is the most granular time interval you have. Let's say you collect the data with the timestamp. So every time you do that and there is an observation, but sometimes you may collect data every hour or every day, or in this case, if you have actually the data every week, well, that is the most granular you have. I think the first thing that you need to do is to understand the decision that you're going to support. So is it let's say, a procurement of the essential products that you need for that case in like every month. So if that is basically what you need, maybe monthly could be an option rather than weekly. But also that's another topic that we don't really cover, which is temporal aggregation. So if you have, let's say, hourly data, or in this case, weekly data, and you need a monthly forecast, so what is the best option? Is it better to forecast at the weekly and then you add up, or is it better if you get the monthly data directly and then you forecast directly? So that is one thing I wanted to mention. So I would go and first understand why I need the forecast in the first place, and what is the decision that requires a forecast. So that will tell you what is the temporal granularity that you need in general. There was another point that you mentioned I wanted to say, sorry, I forgot. What was the second
Can I
part? Sorry.
take that again? So my second question has to do with external factors.
Yeah.
So so how do we
Absolutely.
account for that in a time series model?
Yeah, so basically, I mean, first of all, time series data by itself, they have a lot of important, interesting information for forecasting. So that would be always our first choice, to go with the historical time series of the variable that we have in hand to forecast. Now, as you said, sometimes there might be important variables that affect the forecast variable. So Mitch will cover actually this in regression a little bit. And in ARIMA, there is also an opportunity to include those kind of variables as external variable. But we need also to bear in mind how we integrate them in your forecasting model. Because if you integrate them in a way that requires forecasting that variable, that brings also another layer of uncertainty to your forecast, which might not be necessarily good. Even if I have an evidence that, this variable impacts or affects the time series that I'm forecasting, but we need to remember I may need to forecast that variable itself as well, because I don't know that variable value in the future. So that is one thing that you need to keep in mind. One option that is always helpful is if you can find that there is a relationship between that external variable and the variable you want to forecast, but the relationship has a lag. So let's say if you forecast in the weekly, you observe that if something happens with that variable, let's say 4 weeks or 2 weeks ago, it affects the current state of the forecast variable this week. So that is sometimes helpful to consider instead of forecasting the external variable. But we will cover that in regression a little bit, how to integrate that, and also maybe in ARIMA models.
Very comprehensive, Bahman. I've got nothing to add.
Yeah, thank you. I think also it's also just important also to ensure that the external data file with the time resolutions, and also it covers the same period, so that you're.
Yeah, so just one thing. So someone asked about temporal aggregation material. So FPP3 book, I don't think, except if there is any update, which I'm not aware of, but it doesn't cover temporal aggregation. It covers hierarchical aggregation. The packages Mitch has developed has also package on temporal aggregation, but Mitch is the best person to talk about this, so I'll leave it to him.
Yeah, in a lot of the questions that we've had that I've answered, I've been talking about the mixed time package. It's not quite ready. It'll be finished in 2026, but that will allow temporal aggregation with Fable. As for what you can read about now, the best is probably the Thief package. It has some information. I'll share that in the chat. There's also some research papers about temporal reconciliation that you could read, and you can reach out to us and we can send you more information. So THIEF stands for Temporal Hierarchical Forecasting. And I'm just sharing a blog post on how that works now in the chat. Okay, we have about 3 more minutes before we start the next session. Do we have any more?
So I saw somewhere, I'm not trying to remember what was the question about longitudinal data or something like that, panel data. There was a question. Trying to find it, but I missed it somehow.
Yeah, hi, morning. I'm the
Yep.
one that sent the
All right.
question. So I was trying to find out what the difference is between a longitudinal or panel data versus a time series data. And is it possible to still make use of table to fit a longitudinal data, but rather assume that your time variable is being accounted for using your fixed effects kind of setting?
Yeah. So thank you for the question. I think my understanding is panel data could actually include time series as well, as far as you have a variable related to date time that changes over time. But if let's say you have in your panel data just one column that is about a particular year, let's say, or a particular date or whatever that doesn't change, then there is no time series really in that panel data. So that is one thing that you need to remember. Also, when it comes to the column in your panel data related to date time, you need to remember that we have to convert it as Debra explained, to a testable that has equal intervals. And when I mean in equal intervals, I mean you should have an index that is like observations every month of the year or every quarter of the year and so on. So yeah, the short answer is, in my understanding, the panel data is also time series data as far as you have columns related to date time that changes.
Thank you.
We have perhaps time for one last question. Okay, let's start with the second session of the day. So you can access all of the slides and the materials that you'll need for this session on the website, which Bahman could put in the chat again. Going to schedule at the top. And now we're at the second session of today, time series patterns and basic graphics. So if you click through here, you'll be able to see all the slides, and the slides also contain some code and some figures that you might like to look at and copy across into R to follow along. So we've talked a bit about the packages that we'll be looking at, the main one being the FPP3 package. So hopefully you will all be able to use FPP3 in R by typing library FPP3. And you get all of your install packages. If you're still having issues with that, hopefully we'll be able to get that resolved by the end of the day, either with Bahman in the chat or with your mentors this evening. But you'll see that when we loaded in FPP3, it also loaded in a lot of other packages, including Sybil that you just heard about in the first session for time series data. That Sybil data package is a lot of the example data sets, such as the PBS, the Pharmaceutical Benefit Scheme, and the PRISM data that Debra was talking about in the previous session. Now we're going to be talking about the FEASTS package, which stands for Feature, Extraction, and Statistics for Time Series. And this is what will give us all of the visualization tools for exploring the patterns that exist in our data, such as trend and seasonality. And then on the next day, we'll look at FEASTS for doing more tools of decomposition. Let's go back to the schedule. On the second day, we'll compute features with the FEAST package as well. And then for the rest of the week, will be doing forecasting, and that is using the Fable package. So you can see Fable here. We'll go through each of these 3 packages throughout the week, and I just wanted to flag that we're now looking at the Feasts package in order to explore time series patterns using data visualization. So when I say time series patterns, what exactly do I mean by that? There's lots of different patterns that could exist in a time series that we might want to look for when we visualize and otherwise explore our data. The very common ones that you would want to know about for decision making is the trend. So is the data generally going upward or downward? We also saw in the previous session some examples of seasonality. That first figure that we looked at, this one here, whoops. This one here, you can see the data continuously goes up and down, repeating every 4 quarters. And this shape is an example of seasonality, where there's always less sales in the 4th quarter and more sales in the 2nd quarter of this data set. So understanding the patterns that exist in a time series is pretty important for understanding what models that you want to use in order to forecast the data, so that the forecasts that you produce match the patterns in the data. Again, going back to that example Debra showed you, Debra drew a flat line like this. There is a model that would produce this forecast that's called the mean model. However, that's not a very good model because it doesn't capture the patterns that we saw in the data. And the specific pattern that it doesn't capture is the seasonality. So if we instead used a model that supports seasonality and we had data going up and down, that would be a more reasonable forecast, more accurate forecast for this data set. Other things that you might like to look out for, autocorrelation is a fairly unique pattern to time series data. It essentially means that today the values are going to be very similar to the values that we had yesterday or the day before, and so on. And generally, the further back you go, the less similar it is to today. So you've got this recency pattern that exists in time series that is not commonly seen in any other type of data set. Other things include unusual observations, outliers perhaps. And one of the questions from the previous session was, can we include extra information that I might have about the data? For example, I might be forecasting ice cream sales, and then I might use temperature. When it's a really hot day, I'm going to sell a lot of ice cream. If it's a cold day, I'm not going to sell a lot of ice cream. So using these extra information that you might have available can also be used to forecast your data. And it's one of the patterns, one of the relationships that you should look out for. So here's a few definitions. One of the confusing patterns that, or terminologies for time series is the level. The level just describes what is the center of the values. It's sort of like an intercept, but this intercept, of course, can change over time. Your data might start with very low values and end very high values. If you've got a trend, for example, that's one example of when you might have this change in level. The level is the general area of values at a specific point in time. So low at the start, perhaps, higher at the end. Trend is the predictable increase or decrease in the time series. So these are, the predictable is the key word there, when it is generally going up, persistently going up. It would be an increasing trend. If it seems to always be going down, you have a decreasing trend. And then seasonality and cyclical patterns are closely related in that they're both patterns that repeat over time. So they usually go up and down, have some shape that repeats every fixed or variable amount of time. The main difference between seasonality and cyclical is seasonality is predictable. It has a regular pattern, so the shape of the pattern doesn't change, and the length of time over which the pattern repeats, we call that the seasonal period, is also fixed. So it's over the same length of time, usually a year, and it has the same shape. A cyclical pattern on the other hand, is unpredictable, at least in the long term. It is irregular, so the shape can change a little bit each time, and also the repetition of this shape is variable. Sometimes it's every 6 years, maybe every 8 years, sometimes 7 years. It varies when the peak and the trough is. So I'll go through each of those with an example. On the left here, you can see a fairly constant demand, always at 100. And you can see the dashed line in the middle of these points represents the level. So you can see if the data is all 100, the level is also 100. On the right plot, we have some more variation. This is random variation throughout the data. And you'll see that the level acts sort of like an intercept running through the middle of the data. Now, if my data, the black points, was generally increasing, I will have a trend in the data. And you can see in the dashed line, the level is increasing over time. On the right plot, you can see the black lines generally start to decrease. And so the dashed line representing the trend follows that decreasing pattern. The level of the time series is decreasing as time increases. So in 2016, we had a much higher demand than we do in 2023 or 2024. Here's a visual example of seasonality. Remember, seasonality is predictable. It has the same shape and the same time period. So here we have quarterly data, and you can see every 4 observations, the pattern repeats. We start with a very somewhat large value. The second quarter is the peak, followed by a sharp drop down to quarter 3, and then some recovery in quarter 4. And that pattern repeats itself every year, always 1 year apart. So we have a consistent time period, a seasonal period between each pattern. And you can see the shape of the pattern between every year is identical. So you can see each of these regions has the same pattern. Each year follows the same pattern. Now, seasonality can come in 2 different forms. The first form is additive seasonality, which we can see on the left. And on the right, we have multiplicative seasonality. Most of the time, it is common to see a multiplicative seasonal pattern. The reason why we call it multiplicative is because we have the level of the series, LT, remember that's our dashed line, is multiplied by my seasonality. So when my level of the time series is quite small, and I multiply a small number by my seasonality, then I get a small overall shape. But now, at the end of the time series, you can see my level is higher, so I've got a bigger value for LT. And if I multiply a big number by my seasonality, I'm going to get bigger seasonality. So it's very common to have a cone-shaped pattern in the data for your seasonality. When the level of the time series is small, you'll have a small seasonal pattern, and it gets bigger when the trend increases. On the left, we have an additive time series. So it doesn't matter what the level is or the change in the trend, we have the same amplitude, the same variation in my seasonal pattern. Now, depending on what model you use for this, some models can work with additive seasonality, and some models can work with multiplicative seasonality. There are some models that we'll look at that can only work with one of these types. So it's useful to be able to identify the difference between additive and multiplicative seasonal patterns. Here's an example of cyclical data. This is business cycles in cement production of Australia. And you can see that the time between each cycle is variable. Generally, each cycle, a business cycle, is increasing, followed by a business crash. So then it decreases, increasing and decreasing. But the shape of each cycle is inconsistent. You can see this one was quite smooth increasing before the drop, whereas this one had a little drop along the way. So it varies a little bit. The telltale sign of cyclical data is the period. You can see this length of time in the third period of the data is much longer than this one. Hopefully you can see visually that the line in pink is longer than the line in orange. And the one that followed here, the fourth cycle, is also fairly short. Let me fix up my lines. So another useful way to identify cycles is that they tend to be longer. In the previous example, the seasonal data was repeating every year. So demand was a repeating pattern, 2016, repeating 2017, repeating 2018, whereas the cyclical patterns span multiple years. So far, all of these plots have shown the data on the y-axis and time along the x-axis. And this type of plot is known as a time plot. So I want you to open up R and try to run this code. I'll put that in the chat for you as well. Oops, my chat window is not appearing. Maybe Bahman can type this code or put it in the chat for everyone.
Yeah, happy to do it.
But I'm going to open it in R. Okay, I can't see any of the chat messages. So if you do have a question, hopefully you can unmute your microphone and ask it, or Bahman can let me know, or Bahman can answer it. So hopefully the code from the slides, you can put it into R, and then you can see that it builds on top of what we learned in the previous session with Debra. So in this case, we're looking at the ANSET dataset. The ANSET dataset is a weekly dataset. You can see in the square brackets, the 1W represents 1 week. So I heard a question before about having weekly data. Here's a good example of weekly data. And the key variables for this dataset are airports and class. See that they're both the character variables. So this is the number of trips between Adelaide and Perth for Australia, and their business class tickets. And you can see the week of travel, 1989, week 28. This represents our time index. So time index week, key variables, airports and class, and the measured variable, the thing that we're wanting to explore and visualize and forecast, is passengers. So this code is all from the previous session, where we're now filtering the data so that we only look at the Melbourne-Sydney airport route. It's a very busy connection between two of the cities, the biggest cities in Australia, and economy class tickets. We can combine multiple filters together with a comma. So you can see if I just run this code that I've highlighted, you can highlight some code and click run, or you can also see that the shortcut for this is Control-Enter. You can see running the filter code, I now only have a single time series corresponding to only Melbourne-Sydney economy class travel. Now the new bit of code to produce a time plot is the autoplot function. So I can add another pipe to continue the code. After taking my data and filtering out just one time series, I can then plot that time series, which I've done on the right. So try that out for yourself. If you do have any issues, post in the chat. And if you have been able to produce this plot, I want you to write down what patterns you can see in the data. Do we have an increasing or a decreasing trend? Do we have any seasonality? Any outliers? Any weird stuff happening in this data? Let me know what you can see, and I'll try to get this chat window working. Okay, there seems to be no way for me to look at the chat at the moment while I'm sharing my screen. I'll try to get that fixed. It seems to be a bug with Zoom. I'll try to get that fixed for tomorrow. Bahman, what's everyone saying?
Yeah, so there are a couple of comments. So there is an outlier that hits 0 just before 1990. No seasonality.
Perfect.
Sharp decrease in 1990. So it seems like, so there are some relevant notes here. No seasonality. Someone says is a cyclic pattern.
Yeah, very
those are the
good.
comments. Yeah.
So there's the obvious pattern here that we can see in this data set is this big drop. We've got 0 values for a few weeks in 1989. So this is 1988 starting, and this is 1989 starting, and this is the start of 1990. You can see from the labels. So at some time in 1989, there was a period of a few weeks where there was 0 passengers traveling at all. And this is pretty suspicious. Is this an issue with the quality of the data? Is it possible for there to be no people going from Melbourne to Sydney in economy class? So if you see something like this in the data, something weird, it's a good idea to ask questions. Ask questions to who gave you this data. Have they seen that behavior before? What happened in this time period where there's 0 travels? So I did this, and it turns out that in this time period, there was a strike. The people working for Ansett Airlines, an airline from Australia that no longer operates, were upset, and they refused to go to work and run any of the flights for a period of, I think it is 3 weeks, that there were no flights running for this airline at all. So this is a genuine pattern in the data, this 0 demand period. However, it could also just as possibly be a missing value. And that's why it's important to ask questions for when you see unusual things in the data. The other pattern that I can see, it's pretty hard with weekly data, but I can see at the end of each year, there's this drop in the number of people flying. Why do you think that we might have a drop at the end of the year? And once we've got a few comments, if someone could summarize them by unmuting your microphone, that would be appreciated because I can't see them.
I can read them as, people put their holiday
That'd be fantastic.
season, no much travel, winter season, holidays.
Perfect. So they're the key words that I'm looking for. It's seasonal travel, right? So during the New Year's, people don't travel as much in Australia between Melbourne and Sydney because they're on holidays, less business travel between the two cities. And we can see this pattern predictably every year. So here we'd call this seasonality. There'll be clearer examples of seasonality in other data sets. Another unusual observation that I could spot is this one in 1992. There's another drop, not to 0, but much lower than what is usual. And what happened here is actually a redefinition of economy class. They tried to shuffle how expensive economy and business class tickets were, and they made business class a lot cheaper. So if I look at the business travel, just swapping economy for business, you can see at that same time period, there's suddenly a lot more people flying business class because they made business class much cheaper in an attempt to save the company because they weren't performing very well financially. So back to economy class, there was also maybe some mention of trend. There's a generally increasing trend in the second half of the data, but mostly it's fairly flat overall for the time series. So there is some autocorrelation where the observations are very similar to their previous observations. So that's one time plot. Here's another one. We looked in the previous session with Debra about how to filter out a specific type of pharmaceutical, the A10 medication. This is for anti-diabetics. And we saw also how to calculate the total cost for the government of subsidizing this medication. So this code, again, we can use the autoplot function from the slides. So Debra showed you this code in the previous session. It was taking all of the medication subsidized by the Australian government, looking only at a specific type of medication, the ATC2 drug for anti-diabetics. And then in the previous session, we also calculated the total cost using the summarize function. So now we have just a single time series that we can look at. If I then pipe that into the autoplot function, I get a time plot. What patterns can you see in this time series?
There is a seasonal answer. That's one answer I see.
Yes, very good. I want to go one step further. What type of seasonality is it? We talked about additive and multiplicative seasonality before.
Lubim says
Put in the chat if you
multiplicative.
think it's additive or multiplicative.
Okay, another answer, Francis, multiplicative.
Yep. So one guess
Multiplicative.
on multiplicative.
Yeah, I think
Yeah, very good.
there is only one says additive.
One that's additive. Unfortunately for that one, you are incorrect. This is a multiplicative seasonal pattern, so it sounds like most of you are correct. Remember, a multiplicative seasonal pattern has the level of the time series. That's the center value. So I'll draw the level. Actually, I'll draw the level in the same color. So the level in blue goes through the center of the data, like so. And then we've multiplied this by my seasonal pattern. So this is a multiplicative time series or multiplicative seasonal pattern because when the level is small around here, you can see that we also have a small seasonal pattern. But when the level is larger up here, and we're multiplying a large number by my seasonality, you can see I get a much larger seasonal window, seasonal amplitude. So we get this cone shape where the seasonality starts small and gets bigger as the level of the time series increases. So here we have multiplicative seasonal pattern. And then the other pattern that I hope is quite obvious is that it's generally increasing. So we have an increasing trend for the data. Do we have any questions about trend and seasonality in the data? And how you can spot them with a time plot?
There is a question, can the trend and level be used interchangeably?
Yeah, I think the slides could be improved a little bit. The trend is the change in each observation. So that's sort of like a rise over run. So this slope is the trend. The level is a value that goes right through the middle. So if the level is generally increasing, that means that we have an increasing trend. If I put all these little slope triangles in there, you can see if the level is changing upwards or downwards, we have an increasing or a decreasing trend. But no, you cannot use level and trend interchangeably, because level describes the center of the values, whereas the trend describes the change in the values, increasing or decreasing.
So hopefully this is something.
Another thing I'll go ahead.
Sorry. Yeah, in the session on exponential smoothing models, we talk about this components of level, trend, and seasonality as well, because there is a question about so in this case, what is our level and seasonality for the multiplication case? So yeah, in the exponential smoothing session, we talk about this composition a little bit as well.
Yes, you've got a lot to look forward to. Okay, so I think that's all I had
There
for
is one
time
more
plot.
question, Mitch. So is the seasonal pattern measured from the trend line or between the seasonal peaks?
So the level of the time series is the center. So if you did a moving average or tried to draw a line right through the middle, you want to avoid the seasonal pattern because that's something that varies, and we want to get a line right through the middle. We want to remove as much variation as possible. But in the previous example, where we had some data of zeros, that would decrease the level. So if I'm drawing a level through the middle of the data, it would have a sharp drop here and then increase. Maybe I'd even drop it all the way down to 0 and then increase. Notice that I'm ignoring my end of year seasonal patterns because I want to draw a line through the middle, ignoring changes in seasonality and including effects like trend. Usually it's also bad to include the outliers in your level, but because these outliers persisted for several weeks, they're really more of a change in the level. The level has changed from 20,000 down to 0 for a couple of weeks, and then later on, the level changed from 28,000 down to 20,000 for the second outlier. So the level represents the center of the data, and it shouldn't change if there's just a 1 week drop, like we do for the Christmas holiday period at the end of each year. So these time plots are useful for looking at overall patterns, especially trend and seasonality and outliers. But if I gave you this plot and asked you to find what is the seasonal maximum, when do we sell the most drugs, and when we sell the minimum, it's a lot harder to see exactly which month corresponds to the shape of the pattern. When do we have the most sales? When do we have the least? It's not very easy to tell from a time plot. So for this, we have a seasonal plot. As the name suggests, seasonal plots make it easier to see seasonal patterns. So there's a lot of explanation here, but I think it's easier for me to just show you how this looks. In R, this is the important part of this slide. In R, it's just using the gg_season function. So wherever we use the autoplot function before, we can replace that with gg_season to produce a seasonal plot. So Bahman, hopefully you can put this code in the chat as well, so that everyone can follow along. This time series here is built into the FPP3 package. So if you've been able to load in FPP3, you'll have this data set readily available. And the Oz production data set, if we look at the help file, which you can do with * Oz production. So this shows you the help file. You can see that this data set contains the production of various things from Australia every quarter. In particular, the data set has 6 different measured variables. Let's look at the full data set. Here we have data coming in every quarter, so you can see my time interval, 1Q, represents 1 quarter. My time index, the name of that variable that I've given it, is quarter. And then I have 6 different columns of numbers. Remember, numbers are most likely measured variables. If it was text, it's probably a key variable. And Australians love their beer, so we're going to look at the beer production of Australia. So to do that, I'm using a new function called select. The select function simply selects columns of the data for us to look at. So here I am selecting the quarter column and the beer column because I'm not interested in looking at the other 5 production variables available. To add to the question earlier on using additional information, such as the example I gave with ice cream sales and temperature, in a Sybil, this is where you would store your extra information as well. So I might have a column for ice cream sales and a column for temperature. In fact, there's a different data set that we might look at later called Vic electricity, Vic-elec. This is the amount of electricity produced in Australia every 30 minutes. And you can see the demand of electricity is also related to the temperature in the city. So we have multiple variables that we might like to use both of them in the same model to do our forecasts. But we'll get to that later, on another day. So after selecting quarter and beer, I then use the filter function. This time I'm filtering not on my key variables, so I'm not looking for a specific time series, I'm looking for a specific period of time. The data starts in 1956, but I want to start it in 1992. And that gives me a plot like this. So what patterns do we have in this data? Pop them in the chat. Do we have trend, seasonality, cycles, any unusual observations?
Seasonality, cycle pattern.
Very good. Impressive to spot the cycle. It's not very evident in this view of the data. I think if I didn't filter the data, we can see the full data set has like a very subtle cycle every 6 to 10 years, but is not a very strong feature. The main feature of this data set, if I go back to the zoomed in one, is seasonality. You can see that every quarter, every 4 quarters, every year, we have this pattern where it has a peak production and a minimum production, and it repeats every 4 years. Trough, peak, trough, peak. Now, you might also spot a trend. It looks like it's generally decreasing. That is true. We do have a decreasing trend, but the way it's decreasing is a little bit special for this time series. And we'll look at that with a different style of plot. But first of all, from this plot, I want you to tell me a little bit more about the seasonality. We have a peak every 4 quarters, 1 peak every year, in what quarter does Australia produce the most beer? Is it Q1, Q2, Q3, or Q4? When do Australians make the most beer? And if you can't tell, have a guess. I want you all to put Q1, Q2, Q3, or Q4 into the chat. Have a guess. And it's not easy. I'm not expecting everyone to get the same answer on this one.
Q1,
Is anyone
Q2.
brave enough to put it in the text? What are we getting, Bahman?
A lot of Q1, some Q3, one Q4, but a lot of Q1 and Q3.
Yeah, very good. So looking at this, it's not surprising that we're getting a lot of different opinions because it's very hard to spot when exactly the peak is when we're so zoomed out. If I tried really hard, I might look, okay, this one is Q1 with this white line. So Q1 is down here. So unfortunately to everyone that said Q1, you are incorrect. I believe the peak is in Q3, but even I'm not sure looking at this plot. This is where a seasonal plot is useful. So this was a time plot. If I want to produce a seasonal plot, the only difference is to replace autoplot with GG_season. And depending on when you installed your packages, you might get this warning saying that we've got a new package coming out called GG Time that you should use instead. The Feasts package will continue to work with GG Season for a very long time. And if you've used the FP3 package to make it all work, there will be no change at all. The GG Time package is going to be part of FP3. So you can ignore this warning message, but what is interesting is this plot on the right. Instead of plotting time continuously year after year, I've now stacked all of the years on top of themselves with a different color. So now on the x-axis, instead of years, I've got seasons, time within the season. And I want you to now put in the chat, what quarter do you think has the most beer produced in Australia? Is it Q1, Q2, Q3, or Q4? Which one has the most production of beer?
Everyone Q4.
Fantastic. It's so much easier to see what the shape of the seasonal pattern is now that we're looking at a season plot. You can also see that the trough, the minimum values, are in Q2, and the maximum values are in Q4. So a seasonal plot makes it a lot easier to look at the shape of the seasonal pattern over multiple years so that you can identify when the peaks and the troughs are, which is pretty useful for planning and decision making. Your logistics, making sure that you've got enough medication for the winter period, for example, for cold and flu. Very good. So that's the season plot for beer production. You can see the production is much higher in Q4, and it's much easier to identify the overall production in Q1, 2, 3, and 4. Now, I mentioned earlier the Victorian electricity dataset. It's not one that we'll look at much this week. It is quite complicated because the data comes in every 30 minutes. So you'll notice that we now have lots of data available. 52,000 rows and 5 columns. And this is only spanning, I think it was 3 years. So in just 3 years, we've accumulated a lot of observations of electricity demand. Now, this data set is interesting because of its high frequency nature. If the data comes in at every 30 minutes, you'll see that we get multiple seasonal patterns as a result. We'll have an annual pattern. So if I just do GG season, we'll be able to see the annual pattern in the data. And if I go through this and tell the story, at the start of the year, let's use a different color. At the start of the year in Victoria, which is where I live in Australia, the demand for electricity is very chaotic. It's quite random, where there's some values that are very high, some values that are very low, and that's because it's summer in Australia. And summer has a lot of heat waves, where there's a few days in a row of very hot days, where everyone uses their air conditioners to cool their homes, and so there's a lot more electricity demanded. In autumn and in spring, it's much more comfortable. Perfect weather, no one needs to heat or cool their homes, so the demand for electricity is lower. And then finally, in the middle of the year, you can see in July we have winter in the Southern Hemisphere, and so more people are using electricity to warm their homes, but it's quite smooth, right? There's not as many random increases or decreases because we don't have any particularly cold days that happen in winter. It's a lot more predictable. Another option to the GG season function is to change the seasonal pattern that we're looking at. So by default, it's going to show the annual pattern, the pattern that repeats every year. But if I set the seasonal period to be the week, we can really zoom in and see how the electricity demand changes every week. Most notable here, you can see that generally for Monday to Friday, the weekdays, the pattern is much bigger. You can see the height goes up to about 7,000, whereas on weekends, Saturday and Sunday, it's a bit lower. So this is largely because people work Monday to Friday and use more electricity when they're working. And on the weekends, people don't work as much, and so electricity is lower. What other seasonal pattern can you see in this plot? A pattern that looks like it repeats every day? Can you see that in this plot, we have this M-shaped pattern? Let me draw it up here. So it increases and then it decreases again. And then the next day starts and it increases. We have this M shape and it decreases onto the next day and it repeats. What's happening here? Why do we have this decrease at the end of each day?
Nighttime, lower at night. That's the two answers we have so far.
Fantastic. Everyone's sleeping. People don't use as much electricity when they're sleeping. So you can see we also have a daily pattern in this data set as well, a daily seasonal pattern. So going back, we have an annual pattern with the seasons of the year. We have a weekly pattern with the behavior of people going to work on weekdays, Monday to Friday, and staying home on weekends, not working as much on Saturday and Sunday. And then if I swap the pattern to be daily, you can see when people are sleeping between, say, 2 a.m. and 6 a.m. This is all averages across all of Victoria, so it's most people will be asleep between those hours. And then we also see this increasing pattern in the mornings as people go to work. And then it sort of decreases a little bit and increases again before the end of the day. And this M shape is commuting, when people get ready for work, have their breakfast, and also when people come home from work and start making their dinner. people will use more electricity at the start and end of their working days. There's also something really odd happening here. You can see there's a few days where there's an extra hour happening here. Any guesses for what's happening here? This is a tricky question. So what's happening here is daylight savings time changes. So once each year, Australians will move their clock forward and backwards. And these are the days where we had 25 hours in the day because the clocks were shifted back by 1 hour. So you can see it's just added on to the end of the plot. So presumably there would also be 3 days where it's 1 hour short. We just can't see it because there's a lot of full days overlapping it. So that is a season plot. There will be some exercises for you to complete with your mentors on seasonal plots to identify seasonal patterns. Another type of plot that I wanted to show you for visualizing seasonal patterns is the sub-series plot. And you can use the sub-series plot in R using GG_subseries. So before I show you anything about what that is, I want you to try and do this for yourself in R for the beer data. So put this off to the side. So we produced a time plot using autoplot. We make a seasonal plot using GG_season. And then lastly, we produce a sub-series plot using GG subseries. So try to type that in and see what plot you get, and then we'll talk about what it helps you see. So the code there is using the GG subseries function. And again, you'll get this warning saying, please use GG time. You can ignore that. It works perfectly fine from the FP3 package and feasts for now. Hopefully you can all see a plot that looks like this. Now, a GG subseries plot is pretty commonly misunderstood. A lot of people will look at this plot and just look at these blue lines. Now, the blue lines are useful, but if you just look at the blue lines, you're not fully getting the value of this plot. The blue lines represent the average amount of beer produced in each of these quarters. So it's taken the black lines, which is my time series. The time series is all of the data from Q1 and Q2, separated into separate plots. So that's why we call it a sub-series. We have split up my time series into lots of different sub-series. A sub-series for Q1, you see this looks like a time plot, but just for Q1. A sub-series for Q2, and Q3 and Q4. So the averages makes it pretty easy to say what the maximum and minimum beer production across the year is. You can see the blue line says on average Q4 has the most beer produced and Q2 has the least. But what's more interesting in this plot is actually the black lines. The black lines help you see how the seasonal pattern has changed over time. And here what we're looking for are differences in the trend. So I want you to put in the chat messages, what is the trend in Q3? Is it increasing, decreasing, or flat? Another way of saying flat is that there is no trend for the Q3 sub-series.
So 1 flat, 2 flats, 3 flats, 1 decreasing.
Great. So I would call this flat. It does look like some of these are slightly decreasing, but they're mostly flat. Now, what about Q4? Is the trend in Q4 increasing, decreasing, or no trend, flat?
Clearly decreasing, yeah. Lot of decreasing.
Yeah, so this
answers.
one should be quite clearly decreasing. You can see it starts above the blue line. The blue line's a good indicator for this as well. You can see when the values are generally above or below the blue line. We have a clearly decreasing trend happening in the Q4 sub-series. So if Q3 is flat and Q4 is decreasing, what does that mean for my seasonal pattern? It's changing. If I had flat lines for all of these or increasing trends for all of these, the shape of the seasonality will be the same. But because Q3 is staying the same, the beer produced in Q3 is not changing, while the beer produced in Q4 is decreasing. We have a changing seasonal pattern. So the point of looking at a sub-series plot is to see how the seasonal pattern is changing over time. And for beer production, we're making less beer during Q4 compared to other seasons than we used to. Right? We've still got more beer produced in Q4 overall. This number is still higher than the others, but it's not as high as it used to be. We're producing less beer than we used to in Q4, while the other quarters are staying the same. If I go back to the time plot, and we look only at the Q4 values, so only at my peaks, we can see that it's decreasing as well. So looking only at these peaks, I'll skip a few. That's what the sub-series is, and that line through the middle is the trend, is generally decreasing. Now look what happens when we look at the trough, right? The minimum values in Q2. Now in Q2, it might be decreasing just a little bit, but not nearly as much. So when we originally looked at this time plot and we saw a decreasing trend, what we were actually seeing is the decreasing Q4 production, even though Q1, 2, and 3 is staying fairly similar, fairly flat. So what's actually happening in this plot is that the shape of the seasonality is changing. It's getting smaller, even when the trend isn't that strong. It's really a decreasing trend in Q4 alone, while Q3 and the other quarters are staying the same. That's a pretty tricky concept, so I want to take some time for some questions. Does anyone have any questions for how to look at seasonal patterns?
I'm just asking if this is clear to everyone, or seems like there is no question at the moment, but if you need...
Fantastic. I'll wait a little bit longer, but maybe I've just explained it really well.
So the labeling in this chart confused me. Thought all are Q1, something like that, yeah.
Let's have a look at that.
That's one comment there, yeah.
So perhaps what you mean by the labeling of Q1, this is a facet. A facet is separately plotting each of the sub-series. And so the data for this facet, this plot, is only the values from Q1 of each year. So this is Q1 1995 is here, Q1 1996, 1997, they're all Q1 in this first plot. In the second plot, Q2, each of these black observations is Q2 from 1995, 1996 Q2, 1997 Q2, etc. It's a time series made only of the data from Q2. And the same goes for Q3 and Q4. This line contains only data from Q4 of each year. Now, comparing that with the season plot, the labeling for this one, in this X position, we have all of the data that was matching Q1. So you can see the Q1 values are usually in this range. Each of the lines here have a different color, and you can see the years that they represent in the legend on the right. Again, for Q2 here, the range of usual values is a bit lower than Q1. Q3 increases a bit. This column, or this time point, is all data from Q3 across many years. And then lastly, Q4, our peak. You see how it's more spread out as well? It's more spread out, but it's generally bigger. And the spread is because it's been decreasing that we saw with the next plot, with the sub-series plot. So I expect it'll take you some time to look at these plots and read them carefully for where the Q1 lines up with the data, because it is a very different way of visualizing data than you're probably familiar with. But the seasonal plot helps you see the shape of the seasonality, and the sub-series plot helps you see changes in the seasonal pattern. Go on, Bahman.
There was a question, there was a comment, if you could repeat the sub-series and how we detect seasonality changes through it, something like that.
Yeah, of course. So a change in the seasonal pattern is when the lines don't have the same shape. So you can see in Q4 it is decreasing, but in Q3, 2, and 1, it's fairly flat. So while Q1, 2, and 3 are not changing their shape at all, Q4 is decreasing. And what we can see in the time plot, all of the peaks are decreasing while all of the other months, all the other quarters are staying the same, thereabouts. So the overall width of the seasonal pattern is shrinking because the Q4 beer production is decreasing while the other ones are staying the same. So you can see that the spread of values at the start of the time series is bigger than at the end. It's shrinking because of the reduction in Q4. If I were to exaggerate it some more, what happens if Q3 was increasing while Q4 was decreasing? Well, then it's also going to be narrower. These values are now closer together. So we have a change in the shape of the seasonality where Q1 and Q2 are staying the same, while Q3 and Q4 are getting closer to each other. Q3 increasing and Q4 decreasing over time. Okay, there's some great questions. I think it'll take some practice and some time just working through the exercises, reading these plots carefully, and trying to interpret them. It's not something that you'll get immediately. These are pretty unusual ways of visualizing the data, but they are very useful for understanding the seasonality that exists. So this is the same plot that I showed you. You can see Q4 is decreasing. Another example of this that I want you to think about is the tourism data set. So hopefully, Bahman, you could put the code for this in the chat as well.
It's done, yeah.
Everyone should have the slides up already. Was there a question?
No, this is done. I have already put this in the chat.
Fantastic. Thank you, Bahman. So this code, building on what we saw in the first session for data manipulation, is taking the tourism dataset, which is a pretty famous dataset in the time series world. It's the number of visitors coming to Australia every quarter. And this dataset's interesting because, yes, it's quarterly, but there are 304 different time series. You can see the time index is quarter. We've got 3 key variables, region, state, and purpose, that we saw in the previous session. So Adelaide is the city of South Australia. So these are 2 location-based variables. And we've also got the reason for why they went to South Australia, which in this case was for business travel. And then lastly, the measured variable trips is what we're interested in visualizing. The next bit of code is going to look only at the holiday data, but there's still 76 different places where people go in Australia for holidays. So the code after this, if you're not used the tidyverse and dplyr before, might be foreign to you, but we've included some primer resources that you can learn more about tidyverse. We're going to, for each state in Australia, calculate the total number of trips. And that gives us a new data set that we've called holidays. So hopefully you can run that code and you'll see that we've got a time series which has data every quarter for 8 different states in Australia. Now, with this time series, I want us to visualize it. Let's try and look for some patterns. So if I do a time plot, remember a time plot is done using the autoplot function. Which state has the most number of people visiting for holidays? So you want to match up the color for the line that has the most trips. You can put that in the chat. Which of these states, the colors on the right, has the highest number of trips for holiday purpose? This is a good opportunity to take a guess, do your best.
New South Wales, ACT, these are
Yep.
2 answers there. Yeah.
So a couple of guesses was there?
Yeah, New South Wales.
Yeah, I want to hear a few more. So put your
the most
thoughts in the chat. This is the right time to make a mistake. It's best to make a mistake here where you can learn from it, rather than being quiet and starting to do this for making decisions and getting it wrong when it actually will cost money or lives. So it's important to engage and put your guesses in the chat.
New South Wales, Victoria. Victoria is another answer.
Victoria is also very big.
Yeah.
So the orange line here has the most number of trips. And the orange line corresponds to New South Wales. So to everyone that said New South Wales, congratulations. ACT in red, it's pretty hard to tell the colors sometimes. That's actually one of the smallest. So that's this red line at the bottom. If you're unfamiliar with Australia, ACT is the smallest territory in the country. So not many people want to go there. It's where all the government stuff happens. And then Victoria is an interesting one because you can see up until recently, the Victorian trips has been fairly low, like compared to New South Wales, it's been much lower than New South Wales, but it's starting to increase. And just recently, it was starting to overtake New South Wales. So we might have a shift pretty soon where more people want to come to Victoria, where I live, and less people want to go to New South Wales. So some interesting changes that you can observe in the data with a time plot. Again, with a time plot, we can see that there's seasonality. So we have this repeating up and down pattern in a lot of the states, but we can't very easily say when the peak or the trough is. And so for this, which function should we use to look at the shape of the seasonality? So we've seen three different types of plots: a time plot, a seasonal plot, and a subseries plot. Which function should we use to look at the shape of the seasonality?
GG season. GG season.
That's right.
Yeah.
So let's do it. Holidays, GG season of trips. And because we've got 8 different states and territories, we get 8 different seasonal plots. And you can see that the pattern, the seasonal pattern in each state, varies a little bit. I should have a map of Australia for this. But you can see, let's start by looking at this one. This is Northern Territory. It's one of the hottest places in Australia. When is the maximum number of trips done to the Northern Territory? Quarter 1, quarter 2, quarter 3, or quarter 4?
Q3.
That's exactly right. You can see the maximum here is in quarter 3, and the minimum is in quarter 1. Okay, let's try this with a colder state. What about Tasmania? Tasmania is the closest to Antarctica. It's a very cold state of Australia. When is the maximum number of trips happening in Tasmania?
Q1. That's the answer.
Fantastic.
Yeah.
Q1 is the maximum, and the minimum in Tasmania is Q3. And you can see that's the opposite pattern to what we had in Northern Territory. Everyone wants to go to the Northern Territory when it's winter, because it's way too hot to be there in summer. Whereas Tasmania is absolutely freezing all year round except for summer. So the only time of the year when people want to visit Tasmania is in summer. So with a season plot, even if you've got multiple different time series, you can visualize the shape of the seasonality and compare them using GG_season. Just to complete all 3, I'll briefly show you the sub-series plot. This gets pretty hard to look at when you've got many different time series, but essentially each row represents a time series and each column represents a sub-series, all of the data from one particular quarter. And we could look at this and try to find some differences in the lines across the columns, but they all look fairly flat to me. So I don't see any changes in the seasonal pattern that's worth noting from this plot. Okay, I think we're a bit short on time, so I'm going to skip calendar plots, but there is a package that you can use called Sugar Ants. The code is quite complicated, and the reason why I'm skipping it is because I'm working on improving this using the ggtime package, which will be ready next year. But they will keep the AFRICAST materials updated for next year if you wanted to learn more about that. But a calendar plot is useful for looking at holiday effects, outliers that might happen on a single day of the year. And it's also a nice way of visualizing a long collection of sub-daily time series using a calendar layer. I wanted to go through a little bit of a quiz with you to check your understanding on the differences between seasonal patterns and cyclical patterns. Remember, seasonal patterns are predictable. They have the same seasonal period, so the same time that it takes to repeat each pattern, and they have the same shape every time the pattern appears. Whereas a cyclical pattern is unpredictable over a long time period because it has a different shape and a different length of time for each cycle. So here's the definitions that we've already seen. And there's the differences that I've just described. I'll read it out to remind you. Seasonal patterns have a consistent length. So the seasonal period is always the same, either usually 1 year, 1 week, or 1 day. But cyclical patterns have a variable length. Sometimes it's 7 years, other times it's 10 years. And notice that I said months and years because the length of a cycle is usually much longer. It's usually measured in several years, whereas seasonal patterns are usually months of a year or days of a week. So I want you to put in chat, here's an example of electricity production in Australia. Is this pattern seasonal or cyclical? Have a guess. It's a good time to make some mistakes and learn from them.
Everybody almost so far says cyclical.
Everyone's saying cyclical?
Yeah.
Oh no. I've done a terrible mistake. Or you're following the leader. This is actually a seasonal pattern.
There are two seasonal. More seasonals?
Okay,
now,
congratulations. Who said seasonal?
More seasonal?
Okay, now I've given you the answer. You're all updating it to be seasonal. Well done. So it's seasonal because you can see this increasing pattern. This is the trend, increasing. We're not interested in that. But if I cut this up into each of the seasonal patterns, each of the repeating patterns, you can see it's repeating every 4 observations. The space between each of these patterns is the same. Every year we have the same shape. And notice that the shape is always this increasing, decreasing pattern. It looks the same every year. It might start to look a little bit different towards the end, but that's just a combination of noise and seasonality. The seasonal pattern is the same. There's just other patterns that are interacting with it. Okay, I want you to try again with this data set. This is the amount of bricks produced in Australia. Is this seasonal or cyclical? Bit of a tricky one. It's almost a trick question, well, sort of a trick question.
Again, many cyclical. There is one seasonal, another seasonal, both seasonal and cyclical.
That's the one. Who said both?
Well, there are 2 answers in both.
Fantastic. Whoever said both, you're a clever cookie. This actually has both seasonal and cyclical parts to it. So this pattern that repeats every year is my seasonal pattern. It's got the same shape of sort of like this increase and then a sharp decrease, and it bounces off. So that's my seasonal pattern. But you can also see a cyclical pattern in this data set where it's increasing and then it drops. Oops, that's very dramatic. Increasing and drop. Increasing, drop. Increasing, drop. So this repeating pattern of increases and then sharp drops is a cyclical pattern. Maybe I can type that out. So cyclical, I've drawn in orange. And the length of each cycle is different. This was a very long cycle. and this one was a very short cycle, lasting only 4 years, whereas the previous one might have been 8 years or 9 years. My seasonal pattern is combined with the cycle. Notice that even within each cycle, we've still got this increasing and decreasing happening every year. So this data set has both seasonality and cycles in it. Okay, hopefully you can get this one now that we've had a few to try and practice. This is the amount of retail trade employment happening in the United States. Is this seasonal, cyclical, neither, both? Okay, what are we seeing?
Both, mainly.
Very good. I think you've got the hang of it. You are correct. This is both seasonal and cyclical. You can see these repeating patterns with like a big peak at the end of each year. Everyone's getting hired for doing retail trade for Christmas sales. But what you can also, so that's my seasonal pattern, this repeating one with a peak every year. You can also see a cyclical pattern, let me use a better color, of an increase, decrease, increase, decrease. Now it's not always the shape to be an increase and a decrease. Cyclical patterns could be of any shape, but the main thing is that they're irregular. So in this case, we have a business cycle. And perhaps most memorable to all of us is this crash in the business cycle that happened in 2008, the global financial crisis. So a lot of people lost their jobs. The employment decreased a lot after 2008, and it's been recovering since. But if you're worried about the current global politics and economic climate, we might be due for another crash soon. So this data set has both cyclical and seasonal patterns in it. So congratulations. Seems like everyone got that right. I'm going to skip this one. All right, the last one we'll do for this. This is the number of lynx trapped in, I think it's the United States. But the species of animal is a Canadian lynx. Is this a seasonal, cyclical pattern, or neither, or both?
A lot of seasonal. There is one both. Cyclical, seasonal, cyclical.
Bit of a mix, good to see. So thank you everyone for putting your guesses in chat. So it's good to learn. This pattern is a cyclical pattern. Now there's a few clues for how we could tell that it's cyclical. Look at the shape of each pattern. So it increases and decreases. So that was a small one. See, the height isn't as big. But in the very next pattern, the very next cycle, it increases much more than the last one. So my shape is pretty inconsistent. We had a small cycle followed by a big one. If it was a seasonal pattern, the amplitude, the shape of all of these would be the same. I would have the same height and the same duration for each one. So because the heights of these peaks are all different cycle after cycle, that's your first tip. your first indication that this is a cyclical pattern. The second indication is remember that cycles have an irregular period. So the timing between this peak and the next one is maybe 9 years. But from this peak to that one, looks pretty similar. That might be 9 years as well. But this one is 10 years. Oops. And this one might be 8 years. So it's a bit hard to visually see that. We've got a different type of plot that will help you identify the periodicity of the data, if it's 8, 9, or 10 years. But the irregular length of time between each pattern is an indication that it's a cyclical pattern. So this is cyclical data. So the timing and peaks are predictable with seasonal patterns and unpredictable and over a longer time, several years usually, for cyclical data. So I'm going to skip the lag plot because, to be honest, I never use a lag plot. What I instead always use is a autocorrelation function, an ACF, to visualize how often the data repeats. So an autocorrelation says how similar is today to yesterday, or January to December. It's how similar is today related to the past. And if you have a seasonal pattern, you will have a large peak in the ACF when January is compared with the previous January. When the seasons align, you'll have a much stronger autocorrelation. So let's see this with the beer dataset. So I'll go back to R. What did I call this one? Beer underscore. There we go. So remember this beer data. If I added the same data, but shifted back by one observation, I'll make this a nice color. Color equals steel blue. You can see that these two lines are not very similar at all. The peaks aren't lined up with each other. The troughs are a little bit offset. So the correlation of this is going to be fairly low, comparing this quarter with last quarter. If I go back 2 quarters, so lagging it twice for my blue line, now it's as bad as it can get. They're exact opposites of each other. When the black line is at a peak, let's draw that here, the peak of the black line corresponds to the trough of the blue line. So this will be a negative correlation. They're exact opposites of each other. But something special happens as I approach lag 4. So this is lag 3. When I do lag 4, look how similar these two lines are. And that's because quarter 1 is now compared with quarter 1, quarter 4 with quarter 4. All of my seasonal patterns are lined up, and so I'll get a very big correlation with a lag of 4. So this process is called an autocorrelation function. And if I type ACF with the beer data, what I get is the ACF statistic calculated for each of these lags. So when I lag 1 quarter, they're not very related at all. When I lag 2 quarters, we have a very strong negative correlation. It's very opposite patterns showing up. And when I get lags 4 times, the seasonalities align and I get a very big autocorrelation. And you see if I lag it 2 years back, with 8 quarters, we also get a very big positive number. Now, reading off tables isn't very helpful. I like to plot my data. So if I pipe the ACF results into the autoplot function, autoplot's pretty clever. It knows what type of data you're working with. So it can see that we're working with an ACF. And what it will do is produce an ACF plot. And here's where we can see the periodicity of the data, how often it repeats. What we're looking for is these big spikes, and then we can read off the lag number for them. So we can tell that the data repeats with a seasonal pattern every 4 quarters. Because it's going 4, 8, 12, 16 is when all of these peaks are. So it repeats every 4 quarters. You can also see these blue dashed lines. This is an indication of significance. So if we have something outside of the blue dashed line, we have a significant pattern. So what this is telling us is that our seasonal pattern is significant. It's not white noise random data. Okay, I want to also, we looked at the links data, the Canadian links. When I told you that this was a cyclical pattern because the time period was varying between each one, we can see exactly how many years are between each cyclical pattern by using the ACF as well. So if I calculate the ACF of this links data and plot it, you can see I have a much smoother shape. And this smoother shape indicates that most of the time the pattern repeats every 10 years. But sometimes it repeats every 9 years, and sometimes less often than that, every 11 years. So the variability in the length of the cycle you can read off from an ACF. For a cyclical pattern, we have a smooth ACF. For a seasonal pattern, we have a sharp ACF. So you can look at for a seasonal or cyclical patterns from both the time plot and the ACF. Again, this will take some time to practice. The other thing that you can see in an ACF is trend. So this data set is generally increasing, and we can see that in the ACF with a very positive slow decay. So if you have lots of positive values, it means that you've got a unit root, which is commonly a trend in the data. Why this is the case is because these values up here are going to be close to yesterday, like last month. They're not going to be very similar to 10 years, 20 years ago. So if you've got a trend, the further back you go, the less similar the time series will be. And that's why we have, with low lags, very similar values when we're not moving that far away. But if we're going several years away, the correlation is weaker. Okay, to finish up, I want to talk about white noise, because this will be useful in the final session on day 5 when we're talking about residual diagnostics. If the ACF is confusing to you, don't worry, we'll go back and look at it on day 5 again. And it'll also be used to understand ARIMA models on day 4. So we'll see the ACF several times and get a better understanding throughout the week. But white noise relates to those blue dashed lines that we're talking about. Looking at this data, what patterns can you see? Can you see any trend, seasonality, outliers? I'll save you the time. This data set has no patterns in it whatsoever. I know this because I've generated it from completely random normal numbers. There's no structure in this data at all, unless it was by chance. Now, when I plot the ACF of a white noise series, I can visually test for if there's any patterns. Remember when I said there was the seasonal pattern was outside the blue dashed line, so it was significant? If I don't have anything outside the blue dashed lines, that means that I don't have any patterns in the data. Notice that I've got one observation outside here. That's okay, because it's a 95% test. The blue dashed lines are 95% intervals, and we expect 1 in 20 of these values to be outside just by chance. It would be a problem if it was really far outside the line, but this one is only just outside. So this is saying that we have white noise data. There's no patterns left in the model, in the data, and when we come to the end of the week and we evaluate our models, this would be a sign that we've done well, that we have a good model that has used all of the information available. So ACF plots are useful for seeing the presence of patterns. Trend, if we've got lots of positive values, and seasonality, if we've got peaks at lags 4 or 12, whatever year is, 7 for a daily data of a week, and cyclical patterns if we have a smooth repeating pattern, a smooth shape. I think I'll end it there. I have gone a little bit over time, so I understand if you have to go. But I'll take some time for some questions, and then I'll also set you up with the exercises that you need for your mentor program this evening. So any questions with autocorrelations?
Mitch, there are 2 questions. One is there is a bit of confusion around what a lag represents. And then the second question is about also the pipe operator, because in slides we have actually 2, one from the previous one and the new one. So if you could clarify that, that would be great.
Yeah, very good. I'll start with the pipe operator because that's simpler. The pipe operator, I'd like to say it was intentional that we used 2 different pipes so that we could talk about this. But it's just because we've updated the slides over several years. These days, if you're using R version 4, you have access to a better version of the pipe, which looks like this. Before version 4 of R, we only had access to this version of the pipe, and it's a bit slower. It's slower to type because you've got to write more things, but more than that, it's a bit slower for the computer as well because of how it's implemented. This is implemented in an R package, whereas this pipe is built into R itself, so that it's much faster. There is one feature of the old pipe called the dot. What the dot says is where we should put the data on the left. So this will say, put the left side of the pipe exactly here. The equivalent for the new pipe, which I recommend you use, is that it's now an underscore. That's the only difference between them. But the native pipe is better. Oh, it can only be used as a named argument as well. You have to probably say dot data equals, I think it is. Yeah. So there's no real difference between the 2, other than the native pipe is good if you have a newer version of R. You should use the native pipe. It's a good question. The other question, could you remind me again, Bahman?
Yeah, the other question was
something
about
cycles.
No, about lags. If you could.
Lags. Yes.
Okay. Yeah.
So lags will, a lag of 1. So say today is Monday. Lag 1 day is going to be Sunday. So it shifts the time series back by however many observations you've said. So for my beer data, I've got quarterly observations. And if I mutate, a new column, which I'm going to call lag 1, and lag 1 will be equal to the lag of beer 1 observation ago. So it's essentially saying, okay, our beer production today in this quarter was 410. So 1992 quarter 2, we had 410,000 liters of beer produced. And lag 1 in the column next to it is saying, how much beer did we make yesterday or last quarter, which is 443. So this allows me to compare how much beer I made in quarter 2, which is 410,000, compared to how much beer I made last quarter, which is 443. If I lagged it 4 times, you can see now I'm comparing the amount of beer produced in quarter 1 of 1993, which is 433, and my lag 4, I should write, lag 4, which is 1 year ago now, 4 quarters, the same amount of, the beer produced 4 quarters ago was 443. So it's a way of looking at the past and comparing the values with today. And I did that with a plot to more easily see all of the data, and the same data lagged 1 year. And you can see it lines up very closely. So that is why we had a very strong correlation indicating that we had a seasonal pattern every 4 quarters. It repeats every year. I hope that helped. Do we have another question? I have time for maybe one more question.
There is no question in the chat.
Okay. So the last thing I wanted to show you is to get you started on the exercises for this afternoon. So if you go to the schedule on the website, I've now updated all the times. So if you go onto the website, Bahman will put the direct link to the schedule in the chat. You can see, I think it's at 5 p.m. you'll be meeting with your mentors. This is in Nairobi time, so UTC +3. And to complete the exercises, you will need to, oh, I need to update this as well. You will need to have access to the data that you'll apply your skills on. So you need access to this vaccine administrated data set. Now there's a special bit of code that we've given at the top of the first exercise to set you up with all the data that you need. So I want you to try and follow along in R. So make sure that you've downloaded everything that you will need for this afternoon. By the way, you're welcome to work on these exercises. I encourage you to work through the Learn exercises before you meet with your mentors, if you have the time, just so that you can go through at your own pace and try out all of those plots and data manipulation tools that we've seen today. So to set up your computer to complete the exercises for the entire week, you will want to run this line of code in R. So I'll put that in here. What this code will do is download all of the data sets and all of the code that we've prepared for you to complete the exercises. So you simply run that line of code, and then it will ask you, is it okay to download it onto the desktop? So you can say, yes. You will need to read each of these. So is it okay to proceed? I'm going to type 3 because that's the one that it says yes. So now it's going and downloading all of the data sets, and it has added it onto my desktop. And then it's asking, can we delete the zip file? And we can say yes to this as well. So I'm going to type 1 on my computer. The number that you have to type might be different. You just want to type yes. And then hopefully what you'll see is a new window pop up. And this is a project where you can complete all of your exercises. And you'll notice in your files that we have a day 1 exercise. And this has some code already prepared for you so that you can just fill in the blanks. So this is the Learn section. And I encourage you in your own time before meeting with your mentors, if you have the time, to try and fill in these blanks, complete the code, and interpret the plots. At the end of this exercise, you'll also find some code to get you started on the apply questions. Somewhere here. There it is. So for both the learn and the apply exercises, we've given you some instructions and some code on how to get started, including the data set that you'll need. So you'll see in the data folder, we have a collection of time series data sets that you'll explore with your mentor in the exercise sections. So to recap, I want you all to run this line of code and let us know if you have any issues with that, because you will need access to all the data and the exercises to complete them with your mentors. And then tomorrow and on Wednesday, throughout the week, in order to access the exercises, you go to the very top of R, and then you can click on Exercises. Whenever you click on Exercises, it will switch over all of your code and your project to look like your exercises, and you'll have your data and you'll fill in the blanks for each day. So let us know if you have any questions, any trouble setting up your data and exercises for this course. And as a reminder, to access them at any time throughout the week, you can click the project button at the top and switch to exercises. If you've got all of that, if you've successfully set up your exercises course project, that's all I have for you today. So you're welcome to enjoy your lunch or whatever time, whatever meal you might like, have a break. And we're here to help you set up the exercises and any more questions that you might have. But that's all the content for today. So thank you very much, and we'll see you tomorrow.
Thanks a lot, Mitch. So just to remind you, everyone, we try to upload the video as soon as possible. So you will see everything Mitch has gone through today. Yeah, but you may see it by the end of the day, the video, and we upload everything. So as we go and as we can, basically. Yes. So we will see you tomorrow.
That's right.
At 7 a.m. UK time. Yeah, thanks a lot, everyone.
Fantastic. I'll stop the recording here and we'll publish it as soon as we can. And I'm here, Bahman's here, if you have any problems or questions.